Welcome back to another video. In today's video, we'll be going over radical equations and how to solve them. So let's go ahead and take a look at our first example of a radical equation. So how would we solve this radical equation? So if you take a look at the left side, we clearly have a radical. This symbol indicates a radical, and we have 3x plus 1 under that radical. So we need to get rid of the radical. And if you know anything about radicals is taking the square root of something. So like radical 4 is the same root as square root 4, which is 2. And 2 is 2 squared is 4. So if we were to square the square root of 4, it would cancel the square root. So squaring a square root cancels the square root. So let's go ahead and apply this, or apply that same logic to this radical equation. If we go ahead and square both sides, we'll get 3x plus 1 equals 16, because the radical cancels uh, the square root cancels the radical. So now that we have our equation in this format, it's way easier to solve for x. We just need to simply solve for x using things we've learned in Algebra 1. So we want to subtract 1 from both sides. We'll get 3x equals 15. And if we divide by 3 on both sides, we'll get x equals 5. So that's how you solve this radical equation. However, one thing you need to keep in mind for radical equations is that there are extraneous solutions. So an extraneous solution is like when you solve the radical equation, except when you plug back in that answer you just solved for, you get out it doesn't match up, like it doesn't verify. So let's go ahead and check to make sure that this number isn't an extraneous solution. So if we plug this in, we should get an equation that makes sense. So let's go ahead and plug in x. Let's go ahead and plug in 5 for x. So we're going to plug it into our original equation. So we'll get the square root of 3 times 5 plus 1 equaling to 4. 3 times 5 is 15. And 15 plus 1 is 16. And the square root of 16 is 4. So 4 does equal 4, and that is true. So this is not an extraneous solution, and we can go ahead and include this as our final answer. Now, let's say that for some reason we got out like 14 here instead. The square root of 14 doesn't equal 4. So that would be an example of like an extraneous solution, because what we plugged in doesn't give us the correct output. Like the equation just doesn't make sense. So since this does make sense, it is not an extraneous solution, and we can include that as our final answer. So let's go ahead and take a look at an example when we have a radical equation, a radical equaling a radical. So how would we solve this radical equation? Well, first off, we want to do the same thing. We have a square root on both sides. So if we square both sides, we can get rid of both square roots, which is a win-win. So let's go ahead and square both sides. If we square both sides, the square roots go away. So we'll get x minus 5 equals 2x plus 3. Now we want to go ahead and solve for x. Again, this is very simple. I'm sure you know how to do this. But let's go ahead and subtract 2x and move it to the left side. We'll get negative x minus 5 equals 3. Add 5 to both sides. We'll get negative x equals 8. Divide by negative 1 because we want x to be positive. So then we'll get x equals negative 8. So that is our answer, but we need to make sure that this isn't extraneous. So let's go ahead and plug it back into the original equation to make sure that we get the same output. So if we plug in negative 8 back into our original equation, we'll get negative 8 minus 5 equals the square root of negative 8 times 2 plus 3. Negative 8 minus 5 is negative 13. Negative 8 times 2 is negative 16. The square root of negative 13 equals the square root. Negative 16 plus 3 is negative 13. So clearly these are the same on the left, on both the left and the right side. So we do not have an extraneous solution because it is verified. It is a true statement. Negative square root of the square root of negative 13 is equal to the square root of negative 13. So this is our final answer, and it is not an extraneous solution, which is good. But make sure you're always checking for those extraneous solutions, because on tests, I'm telling you, they will include a question with an extraneous solution, especially if you get like 2 answers instead of 1. Most of the times, on a test, I wouldn't be surprised if one of the answers is an extraneous, or maybe both in some cases. So make sure you watch out for that. So what happens when we have a radical inside of a radical? This is a pretty crazy question, and I can assure you that you will probably see this on a test if you're in AP Precalculus. Because it kind of throws you off. Like if you were to see this question, I feel like I'd be thrown off. I'd be a little confused. But trust me, it's not as hard as you think. It's actually very easy. So let's go ahead and solve this radical equation. If you're finding this video helpful so far, be sure to drop a like and subscribe. And if you have any questions similar to this, you can join our Discord server and ask it there, which is linked in the description down below. So how would we solve this radical equation? Well, we're going to do the same thing we've been doing for the past 2 examples, and we're going to go ahead and square both sides. So if we square both sides, we'll get 3 plus the square root of x plus 10, because that's under the radical, so it won't be squared. So make sure you don't mix that up. We're just getting rid of this first radical right here, equals 4, because 2 squared is 4. Now I want to go ahead and move 3 to the other side so that we can get the radical by itself, so that we can square it again. You could technically square it like this, but it would just be so much extra work, and I highly recommend you don't do that. So if we go ahead and move 3 to the other side, we'll just subtract 3 from both sides, and we'll get the square root of x plus 10 equals 1. Now we want to go ahead and square both sides again to get rid of that radical, and we're going to get x plus 10 equals 1, because 1 squared is 1. And we subtract 10 from both sides, we'll get x equals negative 9, because 1 minus 10 is negative 9. So that is our answer, but once again, we need to make sure that this is not an extraneous solution. So let's go ahead and plug in negative 9 back into our original equation to make sure it gives us a true answer. When I say original equation, I mean the exact equation they gave you. Don't plug it into here or to here, because you might get an answer that like makes sense, but that's because you already simplified the original version, if that makes any sense. So just make sure you plug it into the original equation you're given. So let's go ahead and plug in negative 9. We'll get the square root of 3 plus negative 9 plus 10. All of that is squared, or square rooted, equals 2. So then we'll get the square root, of 3 plus the square root of 1 equals 2. Square root of 1 is 1. And you might say the square root of 1 is plus or minus 1. We're going to be going for the positives when you're doing this, not the negatives. So we'll get 3 plus 1 equals 2. The square root of 3 plus 1 is 4, and the square root of 4 is 2, because 2 squared is 4. So we'll go ahead and end with 2 equals 2, And that is a true statement. 2 does equal 2. So this right here is not an extraneous solution. It is the right answer. So we can go ahead and put that as our final answer since it checks out if you plugged it back into our original equation.